Hello friends, this video on P block elements part 1 is brought to you by examfear.com. No more fear from exam. The objective of this lesson is to appreciate the general trends in the chemistry of elements of the group 15, 16 and 17 elements. So we'll study my P block elements. In P block elements we'll be studying 15, 16, 17 and 18 groups. Group 13 and 14 we have already studied in the previous class. We'll learn how to prepare dinitrogen and phosphorus and also some of its properties of important compounds. We'll describe again the preparation properties of and use of dioxygen and ozone and chemistry of simple oxides. We'll know the allotrope form of sulfur. We'll again prepare chlorine, HCl. We'll also know the chemistry of halogens and structures of oxo acids of halogens. We'll understand the use of noble gas. We'll appreciate the importance of all these elements and their compound in our day-to-day life. So the first question is, what are P block elements? Right? So if you see, this is the periodic table. This is S block on the left hand side. Then you have P block. Then you have D block. And then you have F block. So going by definition, the P block elements are the elements whose the last electron enters the outermost p orbital. Please note, that's why it's called P block, because the last electron enters the outermost p orbital. This you can easily see from the electronic configuration. Helium is the exception here. Helium is considered to be in P block, but actually if you see helium it doesn't have any p orbital. So helium is the only exception. In fact, there is a debate on whether helium belongs to S block and P block. And some textbook says helium is in S block, some says helium is in P block. But even in this case, we'll consider helium as P block. Although in helium, the last electron doesn't enter p orbital. But the general definition is, if the last electron enters s orbital, we classify them as S block. If the last electron enters p orbital, we classify them as P block. If the last electron enters d orbital, we classify them as D block. If the last electron enters f orbital, we classify them as F block. That is how the classification is. Helium is the exception. Helium, since the properties of helium is in matches with the group 18 elements, and group 18 is in P block, so we consider helium also in the P block. The next question is, we now know what are P block element. The next question is, why should we study P block elements? So in this slide, I'll talk about P block group 15, 16, 17 and 18 elements only, because other elements we have already discussed. 13 and 14 we have discussed. So now we'll talk about the uses of typically group 15, 16, 17 and 18 elements of the P block. The first is urea and fertilizers. If you see in urea and fertilizer, nitrogen is used, phosphorus is used, sulfur is used. So all these are my P block elements. So if we talk about human being, the proteins which we have, the muscles which we build, that is also nothing but nitrogen, the proteins, and that is a P block element. In refrigerant we use nitrogen. In rocket fuel we use nitrogen. In the food industry, when you prepare soft drink, baking powder, etc., you use phosphorus. That is also my P block element. You want to make insecticides, weed killers, so here we use arsenic. And arsenic is again my P block elements. If you see the alloys we use antimony also a lot. Antimony is my P block element. Right? If you talk about the oxygen which we breathe, right, in which we or the plants take oxygen, this is again, oxygen is my P block element. The most critical element for our survival is oxygen, and that is P block element. If you see the ozone layer that protects us from the harmful UV rays, right? This ozone is my p block element. Ozone is nothing but you get ozone from oxygen, and oxygen is p block element. The vulcanized rubber you get, right? For this hardening of rubber, you use sulfur, and sulfur is again p block element. The sulfuric acid, the most common acid in the lab that has sulfur, that is p block element. If it has oxygen, that's also p block element. Right? If you talk about semiconductor, in semiconductor we use selenium, and selenium is also my p block element. If you talk about disinfectant of water, we use chlorine. We use chlorine for disinfectant of water, and chlorine is again my p block element. Iodine helps to maintain or to secrete the thyroid hormones, right? If you don't have if you have deficiency of iodine, you get this disease called goiter. So here my iodine that is used to prepare or to produce thyroid hormones is again my p block element. The common salt that we use a lot in our day-to-day life that has Na plus and Cl minus, and Cl is nothing but my p block elements. Toothpaste has a lot of fluorine, right? This fluorine is nothing but my p block element. If you talk about the lighting which you see in a lot of shops, these are all neon or helium is used in this case, right? So they are all p block element. Again, if you see in this case my neon lighting or helium lighting, these are all my p block elements. So these are some of the uses of p block element. This is not the exhaustive list, and please note I have covered only group 15, 16, 17 and 18 here, because group 14 and 13 is something we already discussed in class 11. So these are some of the common use of p block elements. Having understood the criticality of p block elements, especially nitrogen, to build proteins in our for our body, or oxygen, that is the most critical element for our survival. Let's start the chapter of p block element. The first thing which I want to discuss before even going forward with p block element is the concept of inert pair effect. We already studied this effect in class 11, but we'll repeat this. See, the maximum oxidation state shown by any p block element, this is my p block element, all the elements are p block elements, is typically the total number of valence electron. For example, carbon, the valence electron is 4, correct? 1s2, 2s2, 2p2. So the number of valence 2s2, 2p2. If we talk about the second orbital, the maximum number of valence electron is 4. For nitrogen, if you see 1s2, 2s2, 2p3. So the maximum number of valence electron is 2 plus 3, 5. Oxygen, if you see 1s2, 2s2, 2p4. So maximum number of valence electron is 6. Similarly, fluorine, if you see 1s2, 2s2, 2p5. 2 plus 5, 7. So the maximum number of valence electron is 7. So typically the maximum oxidation state shown by this p block element is equal to the number of valence electron. For example, carbon shows maximum of plus 4 oxidation state. Nitrogen will show maximum of plus 5 oxidation state. Similarly, oxygen will show maximum of plus 6 oxidation state. Correct? But if you go down the group, what happens is the maximum oxidation state is not shown. For example, if you talk about Bi, it will not show plus 5 oxidation state. If you talk about Sn, it may not show plus 4 oxidation state, right? So what is happening is the moment you go down, as you go down the group, oxidation state of 2 units less than my maximum oxidation state, or you can say the group oxidation state. For group carbon, the group oxidation state is 4. For group nitrogen, the group oxidation state is 4, right? 5. Similarly, for group oxygen, the group oxidation number of oxidation state is 6. So these elements down the group, they don't show the maximum value. They show 2 oxidation state less. That is what it is seen experimentally, right? So these guys may show, let's suppose this may show plus 3. This may show plus 4, right? So the question is why? Why there is only a difference of +2? Why not a difference of 3 or 4? The experiment it is seen that if you see these s has two electrons, right? These s. So the justification given is, and this is only for my p block elements. Please note, this is only for my inert pair effect, is only for my p block. Why? I'll tell you why. Because if you see p block elements, before this p there's s, right? And if you go down the group, what is happening? Your size is increasing, right? If you go down the group, your size is increasing, but your charge is also increasing a lot, right? Your charge is increasing a lot. So in this case, as you go down the group, the charge increase a lot, right? Charge increase a lot, size increase, but the charge increase more. The increase in the nuclear charge is much more than corresponding increase in size, right? Charge increase a lot, size increase okay, you can say. So with this, since it has more charge, here, the atoms has more charge, it will hog the electrons, it will attract the electrons, and s orbitals, these s orbitals, they are almost very near to the electrons. So these s orbitals will not take part in the bond. Since they will not take part in the bond formation, you have to ignore these for the oxidation state. Because oxidation state, typically, for example, you say CO2, you say carbon is +4. Why? Because it is bonded to 2 oxygen atoms. Correct? So similarly, H2O, you will say oxygen is -2. Why? Because these oxygen is bonded to 2 hydrogen atoms. But when you go down the group, since the charge is increasing a lot and the size is OK types, this is OK types increase in size. So what is happening here is this s orbital, which is just before this p orbital, these s orbitals, they don't take part in the bond formation. So s orbital, they don't take part in bond formation. See, anyway, these will never take part 1s orbital, because the valence orbitals only take part in the bond formation. That is something we know. Out of these valence orbital also, these s orbitals, valence, or you can say valence s orbitals, yeah, typically all the valence orbitals take part in the reaction, in the bond formation. But in this case, as you go down, so the size increase and the charge increase a lot and size increase a little less. So these electrons are hogged by the atoms, and the s orbitals actually, they don't take part, the valence s orbitals, they don't take part in the bond formation. So the maximum oxidation state shown by the lower or the heavier elements in the group is 2 less than my group oxidation number. Correct? Why only 2? Because this is 2s2. Okay.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.